Have you ever broken a chalk before? Obviously, we all must have done this sometimes in our life. Can you further break this into a small piece? Yes, this can be further divided and it will be so tiny that we won't be able to see it through our naked eyes. Such tiny elements which cannot be divided further are known as atoms. Atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. Let us understand each of them individually with the help of a simulator. Here, this orange colored ball represents the protons, whereas the grey balls represent the neutrons and blue colored balls represent the electrons. Now, protons are positively charged ions and present in the nucleus. Electrons are negatively charged and revolve around the nucleus. And neutrons have no charge, hence are neutral in nature. The path on which the electrons revolve around the nucleus is called the orbit. There are 4 types of orbits, namely S, P, D and F. Today, we are going to learn only about the S and P orbits. The inner dotted line represents S orbits. S orbits have a capacity of 2 electrons. Let's add one more electron to S orbits. You can see that electron is not going in S orbits. That means only 2 electrons can revolve around the nucleus in S orbit. Now, outer dotted line, that is P orbits, have a capacity of 8 electrons. So, only 8 electrons can revolve around the nucleus in P orbits. Likewise, D and F orbits have their own capacity to fill the electrons. Now, let's build an atom. First, let's add one proton. What did you observe? Here, hydrogen atom starts forming. When we fill the atom with subatomic particles, the corresponding element will appear or start forming. You can see here that the atom shows a positive charge. Why is this so? This is because the proton has a positive charge. Therefore, the atom shows a positive charge. Now, as we all know that all the elements are neutral in nature, so here we want a neutral atom. How will we get a neutral atom? We must add electrons here. But how many electrons we can add? For one proton, 1 electron is added, because in the nucleus, the number of protons and electrons are always the same. See, atom is neutral now, and we can see that the net charge is 0 and the mass number is 1. But what is the role of neutrons here? Neutrons help to stabilize the nucleus. Since the nucleus in this case is stable, so hydrogen need not include neutrons. Only hydrogen is an exception, where the neutron is not required in the nucleus. Let's see what will happen when we add one neutron to the nucleus of hydrogen element. See, nucleus is still stable, but the mass number is changed, because neutron and proton have their own masses. If we change the number of protons or neutrons, the mass number of an atom will also change. Here, hydrogen atom has mass number 2. If you remove the neutron, the mass number will be 1. The mass number is the number of protons plus the number of neutrons. Let us add one more electron, proton, and neutron to the atom. Have you observed that the element has changed and it becomes helium? With mass number 3 and a stable nucleus. Let's add one more proton to the nucleus. What happens here? You can see here the element changes to lithium. But why the nucleus is unstable? Because here neutron is not added. Let's add neutron until the nucleus becomes stable. See, the nucleus is stable now. Here, atom shows 1 plus charge. But we want a neutral atom. So, what we can do is, we must add 1 electron to the atom. Because to neutralize the +1 charge, -1 charge is needed. Here we got a neutral atom and mass number 6. Because 3 protons and 3 neutrons are present in the nucleus. If we increase the number of protons, electrons and neutrons gradually, we can get different elements with their mass numbers. Scientists discovered that the electrons are uncertain, which means the position of an electron is not fixed. It is difficult to identify the distance of each electron from the nucleus. So, scientists found some areas where the electrons may be present around the nucleus. This area is called the Electron Cloud. If we increase the number of electrons in an atom, the area of the cloud will also increase. Hydrogen, helium, lithium, and more such elements are arranged in a particular structure with their symbol. This structure is called the periodic table. To know more about the periodic table and arrangements of an element, make sure to watch our next upcoming video. If you like this video, do leave a like. To watch more such informative videos, subscribe to our channel. Thank you.